A few days ago we received a card from the Museum of Tenerife, where was written the length of the guanches type, male and female guanches, found in the last explored graveyards. What the Museum of Tenerife pretends is that we find a method to estimate the height of a guanche by only knowing the length of his tibia and then apply this method to real life. Coming next, an explanation of how we face this problem.
When we are trying to solve a problem, it's really important to think about which tools can be useful for us. For this problem, we need it. Absolute and relative errors. 2x2 systems. Linear regression, it's optional. Linear equation. The algebra. And finally, the scatter plots.
The first thing we needed to know was if there was any kind of relationship between these two sets of data. The best way to know that is by plotting both sets of data on a scatter plot. Once we have plotted the data, we could see that more or less all the points were in the same direction, almost creating a line, which means that there's a high correlation among them. The next thing we did is drawing a line, called line of best fit, which allowed us to make a prediction. To do so, we kept in mind two facts. We have to draw a line which follows more or less the direction of the points. That's why we chose a straight one. Finally, we drew the line. We select 2 points and join them with a straight line, but trying to leave the same amount of points above and below the line. We already had the line of the best fit, so the following thing we did is calculating the formula of this line in order to be able to estimate the guanche's height by only knowing the length of this tibia. There are 2 ways to get the formula of this line, and we worked out both.
On the first step, we have to subtract x2 minus x1 and then y2 minus y1. We have to divide the height difference by the horizontal difference. Finally, we have the result of n. On the second step, we put the formula, and if we remember, the formula is y is equal at mx plus n. So we substitute one of the points which the line crosses to get n. Now solve the formula for n. To do so, we have to resolve the multiplication first. When we have calculated the multiplication, we have to move its result to the other side of the equation to isolate n. But remember, in negative form, then we subtract the result by x1 and finally we have the result of n. The final formula is
we have to substitute in the formula y is equal to mx plus n, the x and the y by the numbers of the points a and b. So the formula is the following. Step 2. We have to isolate the n of one of the last equation. In this case, we chose the second one to isolate the n. In this step, we have to substitute the n in the equation whose n isn't rearranged, so the equation is this. Then we have to solve the last equation to find out the m. And the m is equal to 0.00 periodic 27. Finally, we have to substitute the m in an equation whose n is isolate and then calculate the value of m. We'll obtain the n. The n is equal to 0.70723. And the m is equal to 0.00 periodic 27. So the final equation is the substitution method 2. Step 1. We have to isolate the n in the two equations to find out the m. Step 2. Now we have to establish equalization thanks that we have the n isolate. So the equation is like Step 3. In this step we have to solve the equation until find out the number of m. These are the steps of the formula. Step 4. We have the n and we don't know what number is n, so we have to choose one of the step equation and substitute the m. The final equation is the following. Now we know that the n is equal to 0.70723 and the m is equal to minus 0.09 divided by minus 33. So the final equation is
Reduction. Once we have the 2 by 2 system, we have to multiply both equations by any number to try to leave the same variable, for instance n, multiplied by the same number in both equations, but in one of them in positive and in the other one in negative. In our case, both n's are equal, they aren't multiplied by any number, So we only have to multiply one of the equations by -1 and the other one by 1, just to convert one of the n into -n. We have the same variable multiplied by the same number, but in one of the equations in positive and in the other one in negative. We have to add both equations to get rid of the n, because n minus n equals to 0. The next step is working out the value of m in our formula. Now we can't do that because we already got rid of the n. Finally, now that we know the value of m, we can work out the value of n by substituting it in any formula of this 2x2 system and solve it for m. Then we only have to write the entire formula.
The linear regression method. It's supposed the linear regression method is the most exact to get the best prediction. This method minimizes the relative error. It consists in finding out the value of the variables m and n by means of the linear regression. We have to assign, in our case, for the tibia length the x and for the guanches height the y. Bear in mind, we assign to the tibia length the x because it's the independent variable. To start, we organize the data in a table. We have to do several operations. Don't be afraid, we will use the LibreOffice. First, we find out the sum of all values of x and then the mean. The same process with the y. Later, we substitute the corresponding values in these formulas. And we have to add 2 new columns. Having this, we squared the results and then we make the sum of them, adding 2 new columns. Finally, we have to add a last column with the result of the multiplication of the 4th and the 5th columns. When we have already done the multiplication, we have to do the sum. With the formulas of m and n, we get their values and we build the equation.
And this is the final table.
In the end, we discovered 4 formulas, 2 with linear regression and 2 with our method, which allow us to predict a Wanch's age by only knowing the length of his tibia, no matter if it's a boy or a girl. It's supposed that the formula resulting of the linear regression is better because it minimizes the absolute error and the relative error. But we wanted to know how accurate the 4 formulas were anyways. So we made a couple of estimations with each formula and then compare those estimations with their respective real values, using the absolute error and the relative error.
How can we calculate the absolute and relative error of an estimation? First of all, we need to know the real values of a Wanch's height and the length of his or her tibia. Let's suppose that a Wanch's height is 1.65 meters wide and the length of his tibia is 354 millimeters. Now we have to calculate a prediction with our formula. Next step is comparing the real value with the estimation, by means of the absolute and the relative errors. We did this with all the real values from the table that the Tenerife Museum sent us, and then we calculated the mean of all the absolute and the relative errors to establish a generalization. We also made this with the other 3 equations. Here you are the tables. We've already shown you the tables. A curiosity: our method works better than linear regression in both cases, but this is probably because we are doing a few amount of estimations. Maybe, perhaps, if we would do a lot of them, linear regression should be better.